Hi guys, welcome back to the day 6 of Arduino Workshop, right? So let's wait for a few minutes, let everybody start joining the class, then we will start with today's class and what all we will be doing in today's class. Again, like yesterday we did few fun projects, right? I hope you remember that. So today also we will be doing some fun projects. Now what projects we will be doing today? Yesterday we made a plant health monitoring system, right? And we made a piano. Now in today's class we are planning to make a motion detection by which like whenever it detects any motion, it will trigger it. And then we'll use ultrasonic sensor to know the water level in the tank. Using ultrasonic sensor you can do multiple projects. So that all things we will be starting today. So let's wait for everyone. Um, how many people have come till now? Oh, zero. Sheet. Okay, two. Okay. So let's wait for a few minutes. And exact at 7 o'clock we will start the class. And if you have any doubts from the yesterday's class, do let me know. I will explain each and everything. If you have any doubt from the yesterday's class, let me know, guys. Still nobody came. Okay, no issues. If you can see me, if you can hear me, everything, do let me know. Because here I can't see any viewers. Maybe there is a small glitch. And here it is showing that no data, so I don't know. Okay, wait, let me fix that internet connectivity. 1 second. I hope now my internet will be a little bit stable. Do let me know, guys, if it is stable or not. Hmm. Oh shit. I'm disconnected from the internet. Yeah. I am back live. Let me know, am I audible or not? Hi guys, good evening. Hello Kunal. Kunal, today only, currently there are only 6 members. Mhm. So we will wait for more 6 minutes and then we'll start the class. Okay. If you have any doubt, then do let me know. Let me know, guys, if you have any doubts from yesterday's class. So any doubts from yesterday's class? So we'll wait for more few minutes and then we'll start the class. Okay. Okay. Hi. Okay, guys. So we will start the class. Okay. So in yesterday's class, do you guys remember like what we did in yesterday's class? Basically, in yesterday's class, we made two projects. One was piano keyboard, where we played some random musics, where we learned about tone function, where we take like the pin, which pin pin we want to use, and then we go with like how pitch, like in how much pitch it should play, and then for how much duration. That function we learned. Then we played with basic input output pins, where we learned about pull up and pull down things, and by which you will reduce the noises. That was one project. Then we made another project to remind us to put water to the plants, but with a condition only the daytime. So we learned about LDR, which is known as light dependent resistor, where the resistivity of that device changes based on the like light falling on it, right? That was the LDR thing. And then we learned about moisture sensor, where we see the conductivity of the two poles based on the level of water is there, because we know when there is the soil is like isolated, right? But when we start mixing water to it, it will start having a the resistivity of those 2 points will start reducing because of the conductivity due to the water. So we will be reading that thing, and based on that we will be able to identify that should we give water to plant or not. Then these are the two things which we learned. And yesterday nobody sent me a homework of yesterday's class. Why? Okay. mm, okay, no issues. So like, let me know guys if you have not understood anything from the yesterday's class. Then again I will repeat it again. Okay. And yeah. So should we start with the today's class? So in today's class, again, we will be making two projects. One is using PIR sensor. Basically, using this sensor, we're able to identify the motion. Okay, now how it detects a motion? Now, when there is a IR waves, like when you take a thermal camera and check on us, like when you see that night vision cameras, all those things, they will be having thermal cameras, right? What it does, it detects a heat waves which is changing, right? Now, when we human also we also emit heat, right? Now, this PIR sensor will change, like it will always sense that, what to say, like it will try to sense the difference of heat level in the inside a room or inside a like between the four walls, right? Whenever it detects there is any changes in the heat waves, means the radiation which is like which is coming out of us, that heat, whenever it detects changes, it will trigger the pin and it will say that, okay boss, there is a motion here, a motion has been detected. Okay, this is one of the PIR sensor. Now, where do you see this kind of PIR sensors? Now, if you have a smart bulb in your toilets or offices, like generally in presidency we have that in each and every room. So whenever you walk into the room, automatically light turns on. Why? Because it is saving a lot of energy also, right? Because unnecessary, when there is no one, why should the light should be turned on, right? So that is one of the major reason. So what will happen, it will it will turn off the light whenever it detects no motion, means there is no one in the room, right? So we use PIR sensor, but there's a drawback. Sometimes what happen in generally when we sit and work in our like classroom, we usually don't move that much. So the PI sensor, like usually it fails to detect a motion there. Then it thinks that, okay, there is no one, it will turn off the light again, we should dance or something to trigger it, and again the light will be turned on for few minutes, right? So that is a PI sensor. We will make a same thing, where we will be taking a light and we will be trying to glow it whenever there is someone in front of it. Okay, this is one project we will be doing. And the second project which we will be doing is using an ultrasonic sensor, where I will be not writing any code. We will just do a small Google search and how to get the code. Okay, why? Because see, I will never recommend you, like I'll not suggest you to do everything by scratch also, because smart work, right? So you should always do smart work. So basically what will happen, like if once your basic is cleared, so you will be able to crack any kind of course, and you will be able to rectify any kind of errors. Now it's always better to save your time by doing Google search. Like if you have, because what will help you in this is, like you will know what to search in Google and how to get the code and how to implement the code. These are the three things which we will be able to get from the Google. That only we will be, like I will be acting as like I don't know the entire code. We will also Google search of which website to go, how to find out which code to copy, then where to get do the changes and all those things. Okay, so I hope you understood what all things we will be going to do today in today's class. Let me know if you understood with thumbs up, then I will get to know. Chat box, guys. Let me know. Like, did you understood or not? Like, what are the two projects we will be going to do today? Okay. Yeah. Okay. Great, Kiran. Okay. Now should we, and then we will be starting with today's code, which is like motion sensor. Whenever there is that motion is detected, then it should turn on the light. With the same thing, we can put a buzzer also. Like if nobody is in the home and if somebody tries to enter in the home, it can start a buzzer. Okay. So in today's code, we will be learning basic few new functions, how to make a function in a C++ language and how to call it. We learned about void. Now we will be learning about int, where we are expecting something output from that function. Okay. These are the small basic codes which we will be learning today. Okay. Now open your Tinkercad. I hope you have opened your Tinkercad. And this was yesterday's one. Let me delete everything. Okay. So I assume that you have taken your Arduino, right? Now we need a PIR sensor. So just type PIR. The moment you type PIR in the Tinkercad, you will get a PIR sensor. This is how the PIR sensor looks like. Okay. We'll keep this PIR sensor here, and then we will take a light. Now for light, what we'll see? Do we have relay or something? Okay, we have, but we don't have a light. Okay, right? Can it go a light bulb? Because since it's a very high voltage thing, I doubt. Okay, no issues. We'll go with a normal basic light only. It's fine. We'll just change the color of this light, by which we'll be able to know that it is glowing or not. Okay. Now, as we know, signal pins means, like, see, this sensor gives an output in digital format. What is digital format? Again, we learned in our day two class, which was like on or off, right? So, hello. Okay. Now, the signal pin which is given here signal, right? We'll connect it to any of the Arduino pin. I'll connect it to pin number 11 because I don't know simply. Power. Now, what does a power means? Power will be connected to the voltage pin. So again, we'll go and connect it to the voltage pin. Okay, wait. So power pin I will be going to connect with voltage, and it should be red in color. And then ground. Again, we'll connect ground to ground. Ground means negative, right? So, yep. So I hope you have done. Oh, my screen is not shared. I am extremely sorry. Phew. I am sorry, guys. Okay. And now is my screen is visible? Yeah. Okay. So again, let me repeat it again quickly. So you need go here and type PIR sensor. Right after typing PIR sensor, you will get the sensor. Drag it and put it here. Then you will take an LED, which will be which we will be using to detect light. Like to we'll be assuming this is a light of our room, where we will be turning on and off this light whenever any person enters into the room. Okay. Now here, like we have three pins: signal pin, power pin, and ground pin. Signal pin is basically, which is like I have connected to pin number 11. Okay. And then power pin I have connected to pin number 5, 5 volts input. Okay. Then um, ground, ground is basically ground. Yeah, that's it. Okay. Now, after doing this, all these three pins, now we will be connecting this LED also, right? Cathode, again we know cathode is always cathode will always go to negative. So we will make it to negative. Okay. So we have done it to negative, and positive will connect to any of the pin, whichever we feel like to. So I will connect it to pin number 8 because we want something aesthetic. Okay. Yeah. Okay. Till here you have done. Let me know, guys. See the connection. What I have done. I have connected signal to pin number 11, power to 5 volt, ground to ground, and cathode to negative, and positive to the pin number 8. But there might be an issue of resistivity, so we will just remove it here and we'll connect. Try to we will just we'll put a register by which we can protect this circuit. Okay, then we'll just type register here and we'll put which will be 220 ohms, and then I will be connecting this to, yeah. Okay, till here you have done. Let me know, guys, if you have done. You can comment, guys, if you have done till here. Okay, guys, did you understood how to do connection? Then, okay, great. Now we will start with the coding part. Now again we'll go to the coding part and then we will write. Basically we are using two pins. One is input and one is output. So again we will write int. Then int we will be doing something like PIR, right? PIR is connected to pin number 11. So I will just have PIR, and which is it's connected to pin number 11, right? So I will just have 11. Now 11 is our value. PIR is our variable by which every time we call whenever we want to call numbers, right? Because we human beings are very weak in remembering the numbers, so we'll call with the names. So we have given a name to this 11, which is PIR. Okay, whenever I want to call the pin number 11, I will call PIR. Okay, now int, again I have another pin which is LED. Okay, LED is connected to pin number 8. Then these two things are done. Now we'll go with the white setup where we will be using a function to tell to turn on or turn off, right? We will be telling the Arduino, is it the input device or output device, right? So we write void setup. Okay, void setup. Now inside void setup we will be telling the Arduino that what pins need to be connected where. Okay, then again pin mode, M capital MOD pin mode. Why M is capital? Camel's casing, which we learned at the day one of the class. Okay, pin mode, and we will put PIR. Now PIR is an input or output device. It's an input device, right? We will take input and input, and then pin mode. Again LED is input or output device. Okay, done. Now we have told Arduino which pins are being used and for which purpose it is being used. Got it? Now we will again go with the coding part. Now here void loop. Void loop basically means that it will keep on looping. That's it. Okay. Now we will put a condition. Whenever PI sensor detects any motion, it will emit a like it will give a signal of positive signal, right? So we need to detect a positive signal. So whenever it detects a positive signal, what will do? It will turn on the light. That's it. Okay. Now it's a basic, very basic one which we are doing from past 3-4 days. Just pin. Now digital read, DIGITL digital read, READ read, digital read, and in digital read we will be having PIR sensor. Okay. Now PIR sensor whenever it detects one, like it's high, whenever it detects high, what it should do? It should, it should what? It should just start playing it. Okay. Now digital right, DIGITL digital right. Okay. Digital right, and it will be turning on the LED. LED, it will turn on the LED for how many longs? We'll keep it turn on for few minutes, like delay for 2000 we will take. So it will turn on the LED for 2000 seconds. Okay, 2000 seconds. Why? Because 2000 millisecond is equal to 2 seconds. So basically that only. Now, or else what will happen? It will just turn on the. It will just keep the light off. Okay, digital right, and light is off. Till here you have done. Let me know, guys, if you have done, and we will start testing here. Okay, I will start the simulation, and yeah, so I will try to move something here. See, the moment I am moving here, you can see the LED is red LED is as a this white LED is glowing, and again it is off. I'll change the color by which you will be able to see it properly. Okay, then again I will start moving. See, I am moving, the blue LED started glowing, right? It started glowing. The moment I stop moving, still it is on for 2 seconds, and then it is turning off. Right? So this is same circuit which has been used in our homes and offices and washrooms to detect a motion and turn on or off the lights. Okay. Now we can make one more step ahead and we can make it anti-thefting. Like whenever we are not in room, we can turn on this and we can leave the house. But whenever it detects a motion, it will start buzzing around. Okay, by which it will annoy everyone, and thus everybody will get alerted that somebody is trying to enter the room without any permission. Okay, so now let's make that one also. To make annoying to annoy us, what we need is basically we need a buzzer, right? So just take a buzzer, also known as piezo buzzer. Okay, we have taken a buzzer. Now I will connect the positive to any of the positive signals. Like I will connect to pin number 7. No, no, I will not connect to pin number 7. I will connect to pin number 6. Why? Because we will be using tone function, by which we can play some kind of, like, what to say, some kind of rhythm kind of things, right? Now I will connect negative to negative. Okay. Yep. Okay, I have connected negative to negative. Done. Okay, great. Now we need to start writing the code for this, right? Now again we will go to the coding part, and since we have added one more thing, so we will just write int, then buzzer. Buzzer is connected to pin number 6. Okay. Now buzzer is input or output device. It's an input device. Sorry, it's an output device, right? Pin mode, M capital pin mode. Buzzer should be output, right? OUTPUT. Okay. Now this is output device. Now we need to play some kind of tone whenever it detects any kind of motions, right? So we will be trying to play the tone here only. So we'll tone, we'll use tone function. Tone function, which pin to use? Buzz pin need to use. We'll play some music like 490 hertz for 200 milliseconds. Okay. 500 will put, no, not 500. 540 will put 540. Okay, now let's start the code again and let's see how does it goes. Okay, I'll just remove this delay function by which it will not annoy us. Okay, then we'll start playing again. Got it? It Whenever it detected in motion, it started playing. We'll make it more smoother actually, but it was too much, like, it was too much loud. So we'll put some delay here. Okay. Hmm. Again we'll start a simulation. Okay. Whenever we are moving, we are able to play a tune to like to get to know that if somebody is there or not. Now we will be like, instead of writing it multiple times. Do you remember the day 2 of the class, and not day 2, day 3 of the class? We learned about array, how to make an array and how to call the pins from the index value. Remember? So we will be trying to reduce the code from here using function. Now what is function? If I tell, basically function is basically what happens to write, instead of writing the same code multiple times, we make, which we can call it anywhere by putting the input and getting an expected output, by which we no need to write the same line of code repeatedly. Example, pin mode is a function. Now if I was doing it in raw format, there was a multiple codes in behind. If you ever go and see embedded C, proper embedded C coding, this is it's whatever things you are learning here, it's just like a tip of an iceberg, right? So if you go with the proper one, it has so many logics which need to be done. So to make your life easier, we are using a pin mode function which has been made by some great person in Arduino field, right? So we'll also make some functions by which we'll get to know how to make a function, and we'll be trying to implement it. Okay. Let me stop the simulation. And now, do I need something like back from some function? No, right? So I am not expecting anything output from the function. So what I will do, I will just type void when, like, whenever the function doesn't reply anything back to us, like we are not expecting anything from that function, we will be using void. If you are using any, like, you have made a function which we are going to make today in today's class, where I want to find a distance. So I will send the data to it. It will give me a reply which can be a floating point, or which can, like, floating point is basically known as a decimal point value, or else it can be an integer value, right? So that time I will be putting here int and then function name. Okay, so I will here function bus, three times that I have done, don't get confused, bus. Okay, I'm not taking any input from here. I will just play the sound. Okay, so what I will do, I will just copy this part of the code and I will paste it here. Okay, so I have taken two tones which will be played whenever I call this function. Now, function name is bus. Now, to call the function, what I will do, I will just paste it here, function. That's it. Now, see, you can see how much lines of code, like instead of writing the tone multiple times, what I have done, I have mentioned in one function and I have just called that function. That's it. That is the only thing which I did. Right, by which what happened, like I am, like, my code looked more cleaner and I will be able to debug it more easily. Getting my point? Okay, so let's start. How does it act? Let's see. So, whenever there was a motion, it was nice, right? I know it annoyed you, but we got to know how to make this circuit. Now, by making this circuit, we understood how does a IR sensor, like how does a motion sensor works, and we can make anti-theft protection system where if any motion happens, what we can do, we can just play, like we can just start a siren by which anybody can get to know this. In the same place of PIR sensor, we can use, like, identify any gas leakage. If there is any gas leakage, it will start buzzing. These are few projects, like out projects which we can do out of this kind of things. Okay, did you understood till here? Let me know, guys. Did you understood everything? And I, okay, I will send this code and everything in the group also, where you can copy it. Okay. um yeah. Okay, so I have sent in the group also, which you can start copying it if you want to copy. And let me know, did you understood everything or not? If you have understood, give a thumbs up. I will get to know. And if you have any doubt, put it in the chat box. I will get to know what, like, what is the doubt and how can I clarify it. Okay. So we can play some sound. So let me know, guys. Did you understood everything or not? The next topic, guys. Let me know. Should I move on to the next topic or not? Okay. Okay, Amoga. Okay, Pratik. Okay. So we will go with the next topic. Okay. Now, our next topic was to how to do Google search and how to find out how to make a project. Now, since we are in the simulation, we can't do much around it, but we will be going with ultrasonic sensor. Okay, we will be learning about ultrasonic sensor, how does it work, where can we use it, and all those things. Let me give a like overall idea of where can we use this ultrasonic sensor. This sensor you have in your car. If you own a car, you might have seen whenever you start taking reverse, it will show a line, right? And it will start beeping when it is near to the wall. That is an ultrasonic sensor. The same sensor which we are going to use today also, and the same sensor which you will be using in the project also. Okay, that is another ultrasonic sensor. Okay, then you can use it for water level, like to identify how much is the water in the tank. Now, generally, what happens? There will be a floating dome which will be inside the water, and the way the dome, which how the level it goes up and down, based on that it will identify the water level. But what happens is, like for a long term, if you see, water has some impurities which will keep on falling on it, which will make the dome heavy, and it will start acting weirdly. So, if we put a ultrasound sensor which is not even touching the water, what is happening? It is waterproof also, and it is fault proof also. So you can use ultrasonic sensor to identify the water level, right? You can make a digital scale. You know, in my 10th class, 10th, as a project, I made a digital scale using ultrasonic sensor where you can keep the scale and like you can keep the point out the ultrasonic sensor towards that object and you can start getting the value. Now, let me give you a picture how does the ultrasonic sensor works. Okay, let's go to our drawing board. Okay, okay. Now, example, you have an object here. Okay, this is an object. Now, this is an ultrasonic sensor which you have. Now, basically, in general terms, ultrasonic sensor has two domes. Now, why it is known as ultrasonic sensor? Ultrasonic sensor, ultrasonic. It's a sound wave which a human can't hear. Okay, basically, human ear can't hear. Like, basically, if I know, human can hear from 50 hertz to 50,000 megahertz, right? Or 50,000 hertz. 50 hertz to 50,000 hertz. This is a range where a human ears can hear, right? I'm not a biology student. You can correct me in the bottom. I will really love to learn new things. Okay. So ultrasonic sensor goes beyond that, like very low, which a human can't hear it. No, ultrasonic means it goes beyond the human's hearing capability. Right. So what it does, it has two pins. One is trigger, which will make the sound, and is echo, which will hear the sound. For example, if this is trigger pin, like if this is a trigger speaker and this is the echo pin, what will trigger will happen? Trigger will send a sound wave. Okay, it is sending a sound wave. Now we know whenever the sound moves in here, if it like touches any wall, it will reverse it back, right? It will again reverse back. Okay. Now, what does the ultrasonic sensor do? It will try to get the distance between the two objects by dividing divided by 2. Why you will say like why divided by 2? You see, the sound took time to travel from T to surface and again surface to E. So that like the what to say, the sound has traveled two times, right? So it's a double the distance. So we need to just divide it. Okay. After dividing it, we'll get to know the real like distance of the sensor. Okay. Now let's start implementing it. Okay, now we will be doing a Google search. Now example, you want to do a project with ultrasound sensor, you have an ultrasound sensor but you don't know how to do it. Just start typing it. I will just write ultrasonic sensor, ultrasonic sensor. Okay, ultrasonic sensor. Then I will do what I'll do. Okay, with Arduino. Okay, with Arduino I have done. Now there is a few websites which are good websites like how to mechatronics. How to mechatronics is one of the thing. Then you have tutorial points. Okay, random nerd tutorials. These are the few things. These are few platforms which are well reputed, and you will get to know. And you will only get to know when you open it. So I will go with how to mechatronics because this is a good one. So we can see that he's using the display and he's trying to show the distance. Okay. Now if we scroll down, it has given also. It runs on 5 volts. We will get to know from this. Okay, should I connect? the sensor to 5 volts or 3.3 volt. Now, if you look closely to the Arduino board, okay, if you look closely, you will be having 3 volt, 3.3 volt and then 5 volt. Why? Because Arduino works on two different logic, and the issue is there are few sensors which generally runs on 3.3 volts. So if you try to give 5 volt directly, you will burn it off. So always that is an important key. Whatever sensor you are connecting, in which pin you are connecting. So it supports 5 volt, it supports 15 milliamperes, it's fine. Then it has a frequency of 40 hertz, it's fine. We don't care about it. And it has a minimum range of 2 centimeter. It has a maximum range of 400 centimeter. Great. Then it has an accuracy of 3 mm. Okay. Then 3 mm means it can be plus or minus 3 mm. Basically, it's trying to say. Measuring angle is 15 degree. Now, what is measuring angle? Since if you see this drawing board, it is sending and it is giving back. But have you seen that LED, like the light diagram where a laser you put it in it, and if it is in particular angle, then only it will revert back. If the surface is circular shape, or if the surface is like tilted towards other direction, what will happen? The light will go somewhere else, right? Getting my point? What will happen? The light will come and it will bounce and go somewhere else. I will show you here only. Example, this surface is a little bit tilt. Okay, what will happen? It will go ahead and bounce somewhere else. Instead of coming to echo, it will bounce somewhere else. Now, what is happening? Since it is bouncing somewhere else, it shows a huge, like a huge means huge variation. Now, example, in the same place, if this was circular object, again, if it will fall in it, it will bounce somewhere else. It will not come to the echo properly. Then again, if you go with another like softer surface which absorb the sound, again, these are the few limitations of sound sensor, like ultrasound sensor, where it can start giving a false rate. So it says that 15 degree is the minimum. You can't go beyond that. If you try to go beyond that, the object which is there in front of it, it can't accurately identify the distance between them. Okay, so to always the ultrasound sensor should work. If you want to make the ultrasound sensor to work every time, you should make sure that the surface is always straight. It should not be in any angle by which you will face an issue. Okay, this now you will say like, okay, what is the alternative of this if I can't go with ultrasound sensor because it has a rough surface also. There's something called as LiDAR sensor. It also works in the same way, but ultrasound sensor works on sound principle, but LiDAR works on light principle, where it will be putting a light beam and it will get. And generally, lights are more accurate than sound because sound goes everywhere, but light, if you are using a laser light, it will not go anywhere else. Okay, that is the thing. Then it has given a dimension. Okay, we don't care about dimensions. Okay, now this is how the ultrasound sensor it looks. It has given VCC means 5 volts. Trigger, as I told, trigger and echo pin will be there. Trigger means which will produce a sound. Trigger pin, then echo pin which will hear the sound, and ground. Okay. Now see, here also you have you can see transmitter will transmit the signal. Whatever sound waves are been bounced, it will go to the receiver and start calculating. Okay, this is how the trigger pin works. Trigger pin will give us like 10 10 like no, no, like 10 what to say, like 10 us seconds, like it's a very light one which will it will send a trigger signal, that it will wait for a few seconds and it will start getting the bounce, like bounce of value. Now the time it took to get back that sound, it will calculate like from here on, like here you can see 8 cycle sonic burst, right? After this it will try to calculate how much time it took to come. The moment it triggers like, oh, it came now, so the distance between the point it sent and the point it received, it will calculate the value from there. Okay, now you can see how to calculate distance. Distance is equal to speed into time, which we know basically, which we have done in ninth and 11th classes. Okay, now this is the time, as I told, duration is 1.5 milliseconds. The sound travels in the 340 meter per second, and which is basically 34 centimeter per second. Okay, the distance, speed into time. Now, as I told, it will go and come back again. So we need to divide it by 2. Okay, we have divided it by 2. Then whatever to find distance again, like same value. So by which we will be able to get how much centimeter far we are from the code. Now it has given a like if you scroll more, you will be able to see that it has given where to connect trigger pin and echo pin. That we don't care. Then again we can see the coding part. The same thing here also. Trigger pin was low for 2 milliseconds. Then it trigger pin became high, and it stayed for 10 milliseconds. And after 10 milliseconds, it turned off. Now what pulse will do? Pulse will keep on hearing the amount of time taken, duration. What is there? Duration into 0.034 divided by 2 to convert into the centimeter format basically. Okay, to convert it into centimeter format, it is using this formula. Then we are getting this like what to say, we are getting the distance, right? Now we'll also do by seeing the connection. We'll also try to do the in the Tinkercad. We'll go back to the Tinkercad now, and we'll start with the coding part. Okay. Now, we will be keeping. Should we keep this too? I don't think so. We'll just delete the PIR sensor. Okay. Now we'll take a ultrasound sensor. Do we have ultrasound sensor? Yeah, we do have ultrasound sensor. This is a sensor. Oh, this is a different sensor. We don't want this one. Mm, okay, we need sensors. Yeah, ultrasound sensor. There should be in Tinkercad. There are two ultrasound sensors. One is 3-pin ultrasound sensor. One is 4-pin ultrasound sensor. Make sure you take the 4-pin one, which is known as SR04. Okay, this try to take this one. Okay. Now we will be connecting few wires. VCC to power pin, as we know. VCC to power pin red. Then ground to ground. Ground to ground, and trigger to trigger. Echo to echo. Okay. This is some random we took few pins and we are doing it. Now we will go to the code where which they are given. It has told it has used pin number 9 and 10, completely fine. Then it has taken a variable data type as long. It has taken, okay, it has got a distance. Then it is using loop function to get the loop. Okay. Now we'll try to we will copy it. Before copying, we should read also what else has been given. We can read here. It says that trigger pin has been triggered for few seconds. Then it will give values. So it is like all the pins we are very like initializing here. Then it says how to use void setup function. So we learn our void setup function here. Then it says in loop what we need to do at beginning. Then how after getting the pulse, okay, how to calculate the pulse because of 0.034 divided by 2. Okay, and this is how we are able to do the things. Okay, now we'll go to the Tinkercad and we'll paste this code. We'll paste this code down because we don't want to mess with our old code. I just take the pins here and I'll put it here. Now trigger pin, we are, if you can see, the trigger pin is connected to pin number 13, so we will connect it in pin number 13, and the echo pin is connected to pin number 12, so we will connect it into pin number 12. Okay, now trigger is the input device and trigger is the output device, and echo is the input device, right? So we should change that also. So yep. And if you want to debug, if you want to communicate, we need to use what? Serial monitor, which we learned in yesterday's class, and day before yesterday's class also we tried to implement and we saw few things, right? And we need few variables to store few things like long and integer values we need to store. Okay, we will take a variable here by which we don't need to repeat it again and multiple times. Okay, now if we see the loop part, we'll just copy the entire loop part first. Now inside our loop part also we can paste it. Okay, I have pasted it. Now the first pin says to clean the pin, trigger pin. After cleaning the pin, it will be off for 2 milliseconds and it will be high for 10 milliseconds. Then after 10 milliseconds, it will be again close. After it gets close, it will read the pulse, the amount of pulse was received. Then it will divide that many with the 0.34 because it is soil like it's the distance. Okay, and start giving us the value. Okay, now let's check the code is working or not properly, because since we have copied from online, there's a high chance it might not work also. Right, so we will check it. Now if okay, we will open the serial monitor also here. You can see it's showing 110 centimeter. You can see here also it is showing 110. Here it is showing 103.4 centimeter. Here it is only 110. I don't know why. Then we can bring it the range. right? 34, like there's a slight 1 centimeter deviation is there, which I can see here. And again, if I go back, it is changing. Alright, you are getting to know, right, how to do. Like whatever sound has been traveled, like 136 centimeter it is showing. The object is far 136 centimeter. So now it is 132. Okay. Um. hmm. Okay. Sorry for the interruption, guys. Now here we have our object is like 136 centimeter far from the ultrasonic sensor, right? That's 42. We are getting one or two values up and down. Okay, this is how the our algorithm worked. Now what I want, whenever somebody comes, like example, I told, right, the more when I go, like I can put a buzzer in my dashboard whenever my car goes behind. If somebody comes or if it is near to the wall, it should start beeping. Okay, so I can make a condition, I can make a small condition here. Okay, what I will say, ki if distance, distance, if distance is less than 50, if distance is less than 50, what to do? Start the buzzer. Okay, so pin mode, not pin mode, digital right, digital, digital right, digital right, buzzer which is going to buzz, and it will become high. Okay, and we'll turn on the LED also. Okay, done. Or else what will happen, if I don't want, then just shut it off. Don't keep on annoying us, right? That we need to do. So else we will turn it off. Okay, getting my point? Now let's start the code. Wait, let me make it far. Okay, let's start the code. You can see whenever it's below 40, like below 50, distance is 50, it should turn on the light. Okay, why it is not turning on the light? Uh, if you see, if the distance value is less than 50, it should keep on playing, right? So if I go below that also, it should play. Hmm. Why it is not playing? That's a very good question. I will try to put less than and equal to, and let's see which might make it work. Okay, it is taking as a is equal to kind of conditions. Okay, what we'll do, we'll put a range. If it is, if the distance is below 50 and above 0, okay, we'll make above 0, then play sound. Okay, okay, what is wrong? Let's see. It's getting triggered, it's giving us the value. After getting the value, it's trying to trigger on. Okay, digital right, everything is correct. Distance, DIS, DNC, distance, yeah, both are correct only. Okay, since we are facing issue here, we'll just check it out here also in Google, like what's the issue. So yeah, it just showed that how the code runs. It didn't showed. Okay, like mm, okay, I'm also not getting. It should work actually. But it's the correct only. Hmm. As I'll put one more condition here instead of here and doing this. Else if the distance is above or 51, then don't play anything. Let's try it. So we should. Okay. In real life scenario, it should play. I don't know. Is it a glitch of a website or what? Because see, as per the condition, if the distance is below 50, it should turn on the buzzer. Which suppose it's doing kind of 50-50, I can say. Like if I come exactly around 50 or something, then it's happening. And it's happening only for the one time. It's not happening continuously or something. Right. So we need to check out, we need to look out of it. As if I try to remove this. Let me check, guys. If I try to remove the debugging, which is if I try to debug and check it's working or not, it's still initializing. Okay, here it is showing the correct values. The same thing when I'm trying to implement, I don't know why it is not like buzzing where it should buzz. I guess there's an issue with the software or something like software part. So did you got till here? Let me know, guys. The code should run. Should I try with delay? The buzzer is not connected to ground. No. Oh, yes. Cloudy. Thanks for pointing out that, Cloudy. Yes, we have not connected ground only. Oh. Cloudy, can you share your roll number to me? Like in WhatsApp or something? Correct. We have not connected the ground only. Then how will it grow? So let's. Now it is working. Now if it is above 50 or something, then it is going. Okay, great. It's working. Now we will open the buzzer also. Now let's start. Eh, whatever. Yeah. Now whenever we are like whenever it has a n number of length, it will not make any sound. The moment it goes below 50, it started making sound. Yeah, you got this. By which you can now you can tell your dad, "Ki, Dad, I know how this work," and you can start flexing in front of your parents, like how this work, and you can show show this code to them, right? Now I will send this screenshot also in the group. I will try to fit all the entire code. Okay. I am making the code clumsy to make it fit complete in the single screenshot only. Okay, done. So for today, oh, today we have ended it quickly. So in today's class, we made two projects, and I expect to come up with some creative one, right? So did you understood today's class, whatever we have done today? Let me know, guys, did you understood everything or not from today's class? Did you understood everything from today's class? Let me know, guys. So let me revise it again, whatever we have done today. In today's class, we made two projects. One was PIR based motion detection, right? Where we will be detecting motion and try to turn on and off the light or try to identify thieves, all those things, right? Now, how does the PIR sensor works? Our body emits heat. That sensor will try to identify that heat, like heat changes, and whenever it sees that the heat is been changed, there's a change in the environment, heat change in the environment, it will detect it and it will start triggering it. Okay, it will trigger and it will trigger the Arduino. And Arduino will take that if else and condition. Then based on it, it will try to on a buzzer, or it will try to open a siren, or it will turn on the light. Whatever is your use case, it's completely depend upon you and your creativity, right? And same today we learned about ultrasonic sensor also, where Cloudy has helped us to fix the error, right? Okay, thanks. So here also like we like in today's class we made with ultrasonic sensor, where we tried to make a alert system for ourselves when if you don't have a car with this kind of sensors, where when you are taking back and if the wall is near to you, you can start buzzing, and by which you can able to identify, okay, I should stop the car now. Then we can do it in multiple use cases, like where we can use to see water level in the like tank. We can use it for digital scale, to make it as a digital scales. Then we can use it for alert systems, all those things. Okay, thank you, Amoga. And it was actually, if I say honestly, it was my first time taking a YouTube live. I never took any online classes. I generally I take offline classes only. So this was also my first time experience for me, and I also had too many issues during my first days, and now I'm trying to figure it out. Every day I'm trying to fix it by myself. Okay. So my only goal is that like whatever you have understood, the basic concept. Like we always tell our faculties, right? Like we learned, like our faculty taught us 1 plus 1 is equal to 2, and they give us like a huge numerical. It's not like sometimes it is true actually. Why? Because a basic changes, like where you are doing a basic this here your foundation is clear. Now once your foundation is clear, now it's totally upon your creativity. What creativity, a creative idea you can come up with, and how can you make a project out of it, right? I'm getting my point. So it's completely upon it. So we didn't learn anything new. We learned about delay, we learned about digital write, read, we learned about the analog write, analog read, and we learned about something basic PWMs and all basic things only we learned. I didn't went into the core level till now. where you need to when if we do any offline classes, I will be teaching you how to download a library in, because in online ID we can't download a library. So we will be teaching how to download a library, then all those things, right? Based on that only we can start figuring out all these things, and we can make more complex projects, right? Getting man. So that's it. Like, this is completely upon your creativity. So I will request everyone to come up with a great ideas and ping me in WhatsApp or anywhere, right? So where we will be coming up with the new projects, and when we can make, and if possible, if it is possible in simulator, we will try to simulate in tomorrow's class, and whatever idea you have came up with, right? And yeah, and if you really want to do more into it, and if you really want to have a hands-on experience, you can always pin Ramesh sir to have an offline session. I will be happy to come there and teach you guys, right? So in today, tomorrow's class, we will be trying to wrap up each and everything whatever we have learned till now. Like tomorrow, I guess tomorrow we have the last session, right? So I will try to wrap up everything, whatever we have learned from the beginning till now. And due to the issue of network issue in the day one, many things has been like many basic things has been missed out. So I will try to revise all those things also, and we will. That's how we will be closing the topic. Now, since whoever has sent me the projects and what you in DM, you have personally DM'd me, so I will make a note of all that things and I will send it to Ramesh sir. And most probably Ramesh sir is going to take a contest, and whoever perform first, he will be giving some goodies or gifts, something like that. Okay, thank you, thanks everyone, and I hope you enjoyed today's class. Pratik, your session was very analyze how you went through all the basics foundation. Thanks a lot. And actually, I saw thanks Pratik first of all, and I saw like many of you were having a issue with the basics of C++. So I will recommend you, if you want to make your C language properly, like I will give you two links today. Like after this session, I will give you two links. Go through it, and you will be able to learn properly the C language. Now only two languages are dominating in the entire computer world, robotics and like this kind of electronic things. C++ is the main head, and then Python, right? I will be sending both the links. You can go through it, and you can make a C language or any programming language properly. Okay, thank you, thanks a lot, and I hope you enjoyed today's class. Thanks. Okay, have a great day. Bye bye. And okay, before closing the session, we still have 1 minute. Okay, 1 or 2 minutes we have. So if you have any doubt, or if you have like any projects idea which you want to make, let me know. Like I am here only. Like I can see the comment box. Thank you, Ramesh sir. So let me know, guys. So I assume that nobody has any doubts, because still nobody has messaged me, or there might be a delay. Um, is anybody writing a big paragraph of project? Let me know, guys. Okay. So I assume there's no more doubts, because since nobody has replied. Okay. So basically, whatever we have learned till now, be clear with it, and try keep experimenting with it. I know the drawback of simulator is we can't do more with in the simulators. So once your college gets all the components, you can put your you can do a hands-on experience on it, and you can start coming up with more creative ideas and more like these things. Okay, thank you. Have a great evening. Bye bye.